All right. Well, welcome everyone. We're excited to have all of you here in attendance today. I'm James Blair, a senior product manager at Posit over cloud integrations. And I'm joined today by Jonathan Regenstein from the Snowflake side. Jonathan, if you want to introduce yourself.
Sure. Thanks, James. Hey, everyone. Yeah, I'm Jonathan Regenstein. I head up financial services, machine learning, and AI practice here at Snowflake. Actually, formerly of Posit, formerly RStudio, many years ago. So really happy to be talking to y'all about how these two amazing data science platforms come together.
Perfect. Thanks. So we're excited to have Jonathan. It's good to have him back. Like you said, he's an old friend of the company, and we're glad to be working with him again on this joint effort with Snowflake.
Mm-hmm.
I'm going to walk through just some introductory things here and kind of set the stage for what our Snowflake partnership means to us today, some context around what is available and kind of where we see things headed. And then we'll turn the time over to Jonathan to walk through an example use case and demonstration of some of the things that I highlight as we go through a few slides here at the beginning. Just to give a little bit of context, many of you may be familiar with this, some of you may not. So just to give some context of who Posit is, how we operate, we are a company at our core dedicated to this vision of supporting open source data science, scientific research, and technical communication. And the way that we've built our business and company reflects that ideology. We want and believe in open source both now and in the future. And so we have a core commitment to that concept of supporting the open source ecosystem of packages, tools, products, and things of that nature. The way that we do that and the way this all kind of comes together is we continually, since the very beginning of the company, which, as Jonathan kind of alluded to, was started under the name RStudio, and then we've rebranded and renamed the company to be Posit over the past couple of years. We still produce the RStudio development environment. That's still a part of our product portfolio. But from the very beginning, we've contributed heavily to the open source space. Many of you will recognize open source R packages that we contribute to, like the tidyverse or tidymodels, many of the packages that are commonly used in kind of data science workflows. And then over the past several years, we've been continually investing in the Python ecosystem as well, contributing to and creating a number of packages and tools that are available in that ecosystem. As adoption grows for these open source tools, one of the things that we've observed is that many individuals bring those tools and those open source frameworks into their organization and start using them to solve business critical problems. And with that kind of transition, there comes an additional level of sometimes scrutiny, but also requirement for how those open source tools are managed, maintained, delivered so that they meet enterprise requirements. As a result of that, we have a number of commercial or professional products that we provide that exist to support the open source data science ecosystem within the enterprise. So our commercial products focus on things like security and scalability and auditability, things that most organizations care about. Individual practitioners or users or students or hobbyists may not think as deeply about those problems. And so they benefit from the open source side of things. And then once those open source tools get adopted within large scale organizations, we provide commercial tools to support that sort of transition and make sure that those open source tools can continue to solve business critical problems over time. And then we take that investment that comes in from these commercial tools and then reinvest it back into the open source ecosystem. This sort of framework that we've grown to call the virtuous cycle on the Posit side. To give a little bit of additional just context here, the collection of professional tools that we provide, we refer to as Posit Team, but it's primarily made up of three distinct pieces. There's Posit Workbench, which is where developers, data scientists, actuaries, statisticians will spend the bulk of their time. It gives developers access to tools like RStudio, VS Code, the new development environment that we've been creating called Positron, Jupyter Notebook, Jupyter Lab. There's all these options available so that you can use the tool that you're most comfortable with. And then using the collection of open source packages, either on the R or the Python side, or maybe you're mixing both together, you work with and analyze data. And Posit Workbench gives you all the tools to do that within an enterprise organization. On the complementary side of that, we also offer a product called Posit Connect that allows the developers or data scientists, whoever they might be, to share the results of their analyses with a broader audience. Those results can be something as straightforward as a static plot that was created and we want to share that and we want to do it in a secure way, or it can be something much more dynamic like a dashboard or a web application or even an API that other development teams within the organization are going to use to bring some of the data science work into either their product or their tech stack. So Posit Connect provides this bridge between developers and the work that they're doing and end users, business users, being able to interpret, understand, and view those results securely and in real time. And then as a third part of this Posit team collection, we have a tool called Posit Package Manager that allows organizations to control at the repository level what R and Python packages they make available. It has auditability functionality. It provides some security functionality as well for organizations and gives you the option to distribute your own internal packages and make those easily accessible to end users. And we've seen quite a bit of great adoption across the board on the 3 products here. Now, the reason that I bring this up is because this concept of open source and commercial, the way in which they blend together and work together is really like very evident in the work that we do with Snowflake. So if we take just a moment and I'll talk to this very lightly and Jonathan may touch on it a little bit more deeply, right? But Snowflake as a platform really tries to eliminate data silos, make it as simple and as easy as possible to access data artifacts, things of that nature under one single access point. Snowflake provides this gateway. There's security and access controls that Snowflake makes available. And then users can come in and work with the data that's available to them in Snowflake. And the tagline there is that it just works. And our goal has been to make it so that Posit tools and as an extension, users of those tools can operate in a similar way, that it all just works. That if I'm a developer inside of Posit Workbench and I want to work with something inside of Snowflake, it should be able to be as easy as possible for me to do that without introducing any unnecessary friction. Over the past year or so, we've actually made a tremendous amount of progress in that direction by investing in a couple of different key areas. And so I want to highlight what those are, kind of talk about what's possible today. And then, like I said, I'll turn the time over to Jonathan to walk us through a use case and an example. For today, and this slide is a little bit wordy and I apologize for that, but just to give a little bit of a architectural foundation here, one of the things that we're very excited about is that we've worked closely with Snowflake over the past several months and have now delivered a solution that enables Posit customers to run and access Posit Workbench directly within their Snowflake environment through what Snowflake calls Snowpark Container Services. So I'm not going to jump into all of the details today. We'll look at a little bit of an overview here, but the idea is as a subscribing customer inside of Snowflake, I can come to the Snowflake marketplace. I can subscribe to Posit Workbench there. If I'm a Posit customer, I can apply my existing Posit license to that service, and then it will spin up and create a running version of Posit Workbench that's fully within the confines of my Snowflake environment. Users authenticate into it using their Snowflake credentials, and then they can query and interact with other Snowflake resources directly from there, and everything operates within the context of Snowflake itself. Just as an example of that, here's what that application looks like to a certain extent. If I'm an account inside of Snowflake and I've subscribed to this, my administrator goes through the process of configuring and setting this up, and then the end user can come in, I can launch the application, takes me right into Posit Workbench. From here, I can start my new session, whether that's using RStudio or VS Code or any of the other tools that we provide. And then from there, you can see down below that I have the option to sign in to my Snowflake account or to determine which particular role I want to use within this account. And then it makes it very easy once I've signed in here to come in and automatically connect into Snowflake, see what data I have available to me, explore that data, interact with it without the need to establish my own credential chain or manage my own username or password or token rotation or anything of that effect. Posit Workbench handles all that underlying authentication for me, and it's very easy to get in and just start working with the data that's available inside of Snowflake. On the complementary side, we've introduced a few distinct new features inside of Posit Connect. One of which is similar to what we see on Posit Workbench. We have the ability to configure OAuth authentication into Snowflake. What this means on the Posit Connect side is that if I'm a developer and I'm building some sort of a dashboard, and this dashboard is built on top of some data inside of Snowflake, and then I want to share this dashboard with my company or my department or whoever it might be, a common thing that we've seen is that in many cases, there are very granular permissions defined on that data. So-and-so can see this slice of the data, so-and-so can see this slice of the data, but there's requirements or there's regulations that prohibit user A from seeing the same data as user B. Historically, this has been a difficult problem to solve when it comes to building business critical or business analytics type applications, because historically we've relied on things like service accounts to give us a shared access into the underlying data. But then how do we take that service account and create an even narrower scope for the specific user who happens to be viewing the application at a specific point in time? And I've seen all kinds of creative and clever solutions that we feel good about, but security doesn't. And we just kind of live in that world. But the things that we've introduced, the changes that we've introduced to Posit Connect, make this a much easier path to creating applications that provide true viewer level permissions for the underlying data. So in practice, what this means is a developer can create an interactive dashboard, application, whatever it might be, share that with a large audience on Posit Connect. And when they publish that application to Posit Connect, they can specify this application requires Snowflake access. When a user visits that application, let's say it's me, I visit the application, I log in, here's what I see. I see a dashboard that shows me all the data of a given table inside of Snowflake. Here it's filtered and broken down by region. This is some loan data, so I can see information about the individual fields down below, and I can see an overview of all the different regions that are represented. Now, if I shared this with somebody else, let's say this other person was responsible for and only had access to information about the West region represented in this data. Well, if I share this with them, they'll visit the link, and the first thing they'll see is a prompt to tell them they need to first authenticate or log in to Snowflake before they can view the dashboard. So they'll go through that process, however Snowflake authentication's been configured, they'll log in, and then when they view the dashboard, they only see data from the West region. The benefit here is as the application developer, I didn't have to do this logic myself. I don't have to go through and write a bunch of code that says, if user is in group B, show only this data. If user is in group C, only show this data. I've seen that pattern. It works, but it's brittle and it's full of security issues and challenges. Here, we're relying on Snowflake to manage all the data governance and access control. Posit Connect just forwards on the identity of the logged in user, and Snowflake uses that as it returns results of the queries that are being executed. So the only data coming back from Snowflake is data that this specific user has access to. I could have 100 different users all logged in viewing this dashboard at the same time, all of them with different levels of permission to the data in Snowflake, and they would all be seeing different views of the data because the data permission is coming based on their permissioning within Snowflake. Okay, the last thing that I want to touch on just briefly, and then I'll turn the time over to Jonathan, and he'll cover this a little bit more in depth. This is a little bit more of a recent development, but there's a new open source package that we've worked on here at Posit called Orbital that we've been really excited about, particularly as it relates to what this makes possible inside of Snowflake. I'll give a high level overview and then turn the time over to Jonathan to cover this a little bit more in depth. But the concept of Orbital is to say, I've taken some data, I've created a local extract of it, and I've trained some sort of machine learning or statistical model on that data. Maybe it's a tree-based model, maybe it's some sort of regression analysis, whatever it is, I have this final model object, and that model object will allow me to generate predictions on new data. Now, if you've used the tidymodels framework or have read about it or are familiar with it to some extent, one of the advantages that framework offers is it gives you the ability to not only train and tune a model itself, but to also embed within that model definition any pre-processing that takes place prior to the model fit. So if I normalized values, if I imputed missing values, if I did anything clever in my pre-processing to prepare the data to generate the best possible model, all of that can be captured in this tidymodels object that I end up with. What Orbital does And this is, I'll mention this caveat up front. It only works for certain model types, and these are well documented on the website and documentation. But what Orbital does is it will take this trained R model object that we have and convert that object into native SQL, which means that in the context of Snowflake, I can take this model definition that typically would require me to have access to an R runtime in order to run and generate new predictions. And instead, I can turn that definition into a SQL statement that I can then store within Snowflake as a view, perhaps, or a stored procedure. And now all of a sudden, my model execution and prediction is not happening in an R session somewhere. It's happening in a Snowflake warehouse. And it's happening lightning fast because it's part of Snowflake's native dialect. It's happening in SQL. It's well defined in SQL. Snowflake's query optimization works. Everything that Snowflake does well comes into play. And we've seen dramatic results with a number of different customer accounts where model prediction pipelines that previously took days, hours, or days now take seconds or minutes. And it's been a dramatic time savings because we're able to take advantage of the full compute capability of what Snowflake warehouses have to offer. I'm actually not going to run through this because I think Jonathan's going to give a little bit of a walkthrough and an example here. So I'm going to stop sharing here and actually turn the time over to you, Jonathan.
Awesome. All right. Thank you, James. So I'm going to share my screen, and everyone, if you can't see the screen I'm about to share, let me know, and then we can kind of get into it. Okay. Can everyone see what looks like a Snowflake marketplace right now? Yes. Okay. Awesome. Great. Okay. All right. Thank you, James. So yeah, so we're going to go through, a few, really just an example of kind of what James was just talking through. Before I get over to the example of running Posit though on Snowflake, I actually thought I'll spend a few minutes just showing y'all what Snowflake looks like, because it occurred to me that probably a lot of the people on this call are heavy Posit users, probably Posit native people. You might not have seen Snowflake or really know much about it. So I'm just going to spend a few minutes on it, and then we'll get over into the power that comes from being able to run Posit and RStudio natively inside of Snowflake. So in my role at Snowflake, I really focus on financial services and machine learning, data science, and increasingly artificial intelligence side of that world. So the thing I am showing on the screen right now is what's called our Snowflake Marketplace. And this is frankly a really big reason for why a lot of financial services enterprises gravitate over towards Snowflake. This is actually one of the reasons I first started using Snowflake when I was building a data science team. This marketplace has just a growing number of very valuable data sets to financial institutions. So I'm going to talk about almost everything from the lens of a financial institution, but this applies pretty broadly to enterprises that don't just need data fast, but they need a secure, reliable way to get their hands on that data. And that's kind of what the marketplace provides. So I'm just showing y'all a quick example here. I went up to the search bar, I typed in financial essentials. We're going to be working with this first one, this kind of free finance and economics data. But you can see there's just typing in financial essentials, there's a lot of different interesting data sources on here. Every time I come here, I find new things that look really interesting to me. If I were to click on one of these by request, it would reach out to the provider of that data. Probably they would say, why do you want this data? Are you an existing customer of whoever the provider is? If I said no, I would talk to their sales team. If I said yes, we would figure out the terms of the data that I purchased from them. And then from there, I would be able to do something like this. So this is a free data set. So when I click in on a free data set like this one, it takes a few seconds to spin up. So I just kind of already have it going here. I've already grabbed this data and put it into my Snowflake account, so we don't have to go through that. But normally, instead of saying open over here on the right, this would say get. So I would click get, and then lo and behold, over in my Snowflake account, this data set would really almost automatically appear there. And for this free data that we're going to be kind of looking at today, it's some macroeconomic data. really nothing too intense. We're not going to get too heavy into the data work today. But you can imagine for financial institutions that have hundreds and hundreds, sometimes thousands of data sources that they're getting data from, to be able to have it all delivered in a centralized and, really importantly, secure way, it's a really big deal to these enterprises. So when I say secure, what I mean is when a big bank or a big asset manager, even if they want to just sample a new data source, their security team is going to say, well, we can't just let them give us a link. We can't just hit their API. They can't even just email us a file because we don't want you to open up some foreign file that could have some malicious code in it. If it's being delivered via the Snowflake marketplace, and that's already a blessed vehicle of delivery, that really streamlines. In some cases, you don't even have to go through those security reviews because it's kind of a blessed way to deliver the data, and it just gets updated again really automatically. You don't have to do anything to update the data because it's actually being done by the provider. So that's just kind of a quick look at why Snowflake is very prominent in the world of financial services. A lot of it starts with, we want this new data. That then leads to, okay, let's look at all the amazing kind of tooling and warehousing, and now increasingly machine learning and data science work I can do on that data inside my secure environment. So kind of data is kind of level one. Level two, we're going to be working with what we call a native app today. So that's what the Posit Workbench is. So James mentioned that what makes this possible is what we call Snowpark Container Services. Through Snowpark Container Services, it's kind of exactly what it sounds like. It's our containerization feature. If you're familiar with Docker, you can just imagine it as a way to Dockerize anything you want. Doesn't have to be RStudio. It could just be a big C++ code base, and you want to Dockerize it, put it up into the cloud, and start running that container. Native Apps powers that. So in this case, the Posit engineering team has done all of the hard work of putting this into a Docker container and making it very easy to kind of pull down from the marketplace. So that's what we're looking at here. This is what the marketplace for these apps looks like. We've pulled down the Posit Workbench marketplace. I've put it into my account, and if I were to click on this, it would kind of spin up into this little homepage right here, which you can see is giving me this warning because whenever I get on webinars, I get these nasty grams that things have been disconnected. But that's kind of the machinery of what's going on here. So I kind of start off in the marketplace. I pull in the data that I want to pull in, okay, and then I kind of toggle over to this native apps tab here, right? So it's like data products, then over to apps, where I have this Posit Workbench, right? There's a ton of like native SQL work you can do inside of Snowflake, of course, and that's where a lot of the data engineering work happens. But for our purposes today, we're kind of go from the marketplace over to this native app. And then once I click on that native app, I get this screen here. So if you've used Posit Workbench before, hopefully this looks really familiar to you. What's going on here, though, is that this is actually running natively inside my Snowflake account. Okay, so that's why you can see it says the Snowflake computing up here in this tiny little URL up there. All right, so when I click on projects, if I wanted to spin up a new project, I could do that from here. That's kind of what James was showing. I already have this one up and running. It's going to give me another little nasty note right there. So this is now what my RStudio environment looks like. So I've kind of progressed from the marketplace to where I pull in data through native apps. Now I've got Workbench up and running. And hopefully this looks, again, really familiar to anyone who's an RStudio user. I could have clicked on VS Code, or I could have clicked on Jupyter Lab. But for our purposes today, we want to look at RStudio. This is also a really big deal because you can already, of course, run SQL natively on Snowflake. There's actually a lot of Python you can do on Snowflake already too. But running R natively on Snowflake would require kind of setting up your own Docker container right now. It actually turns out to be a pretty heavy lift to do that. So this has been extremely valuable to our customers who want to run models, do data science natively on Snowflake. All right, so now we're kind of set up. We've spun up the RStudio IDE here in Snowflake, and now we have a few cool things available to us. So over here on the right-hand side, I'll just kind of click around a little bit. What we're doing here is we're peeking into into my Snowflake account right now, right? So for all intents and purposes, I don't really need to be going back to my Snowflake snow site. Snow site is kind of what we call the user interface of Snowflake for people who want to glance at their data. I don't really need to do that anymore, because when I loaded up my libraries, and then James showed y'all a really easy way to do this. I'm still doing it the old-fashioned manual way of just entering all my credentials. Once I established this connection back to Snowflake, I can peek into all my different objects. And in fact, as we kind of go through this code flow, and I'll show you guys how to pull data in from Snowflake, create new objects, save it back to Snowflake. If we just refresh data, connection data up here on the right, we would see all that refresh. So for me, when I'm kind of doing work in this world, once I'm over here to Posit and I've kind of spun up in RStudio session, I don't need to go back and refer to Snowflake. You can, of course, at the end of the day, go do that. But at least for me, I'm used to just having this one development environment, so that kind of seamless integration between this native app and your Snowflake environment is really valuable for people who want to work in this world. All right, so what are we going to be doing today? Let's kind of just go through a little bit of an example, and hopefully it'll help prove out the power of what we're doing here. So I'm gonna kind of eventually get to that Orbital workflow that James was talking about. I'm gonna kind of build off of the blog that Posit published on running tidymodels using Orbital natively in Snowflake. But I'm also going to bring some macroeconomic data to be part of that workflow. A really simple look at macroeconomic data, just a couple of time series. But I think you'll kind of get the idea of how, starting over in the marketplace, we can just build these different data estates, which is really how we get more value out of our models. So that's what we're going to be doing today. Two external resources I'll point out to you guys at the end, but I'll just show them to you now. So one, this is the blog that kind of walk through in detail how to use Orbital with Snowflake. We're going to see how that works in just a second. Two, this blog here, a lot of the macro work that I'm doing is contained in this book that I wrote with Professor Chava from Georgia Tech, a guide to exploring macroeconomic data with R. Nothing too fancy in here. We're just going to be exploring data, visualizing the data, but then I'm going to add that data to this blog post, basically, to kind of show the power of what happens when you have your data and your workbench and all your compute in one place. All right, so that's kind of the mission here for today. The data we're going to be working with is all contained in this. I'm going to just toggle a little bit so people can see it, because there's a lot listed here. I have a database called JR_DB. So this is my database within Snowflake. And then all the data sets I'm working with are in our schema called public. Okay, so within Snowflake, kind of just the vernacular or the vocabulary we use is we have a database, and then we have a schema. And then inside of that schema, we have different tables, different data tables. If you hear someone refer to a warehouse in Snowflake, I think James referred to a warehouse. A warehouse in Snowflake is actually your compute engine. So that's where you're kind of spinning up CPUs to run your work. So that's kind of the breakdown in Snowflake. We got our database, our schema, our table, and our data warehouses. So within public, it's not going to let me do that, is it? Oh, okay. So within public is kind of holding all the data that we have. I've been kicked out of my connection because I'm on this screen, but that's okay. Everything's already loaded up. So within that database, there is a table called Trez_data. That came from the marketplace. So that place where I was toggling over, looking at the marketplace, that free data that was financial essentials. Within that free economic data, there's treasury yields, right? So basically, I didn't want you guys to have to sit here while I did this, but I grabbed some treasury yield data from that free marketplace, and I plunked it over here to the database that I wanted to use during this session, right? So one thing that's really important about that, just to reiterate, is that even though this is free and public data, the data is never actually going outside of Snowflake, right? So once it's been shared on that marketplace by the data provider, everything is staying within this wall, so to speak. So that's important for security reasons. No kind of malicious code is being introduced into this data. It's not going to walk away on someone's laptop because it's all staying on Snowflake. There's full auditability of this, right? So if someone were to change this underlying data that I'm calling TRES data, which is very simple data, but if it were complex and we were to make big changes to it, the full lineage of what happens to that data from the time it's imported to the time it even gets put into a model, all of that is tracked in Snowflake. So you can always kind of backtrack to the lineage of your data. The second you kind of go local, I guess, so to speak, if you were to just kind of plunk this onto your desktop, I mean, nothing wrong with that. I do a ton of work on my desktop when I'm kind of writing and working on projects. But from an enterprise perspective, that can be a big no-no, breaking that lineage. So anyway, that's just kind of an aside on why this is important and why a lot of enterprises kind of keep things native to the cloud like this. All right, so in any event, we've got this treasury data. Here's a little snapshot of it. It's again, it's nothing fancy. These are the yield to the interest rates on treasury instruments going back to 2005. The reason I only went back to 2005 is that the data that we want to be modeling eventually is from that blog post. It's really only from the last few years, so we don't need to go back too far in time. But we could have gone back all the way to the 60s if we'd wanted to. Just didn't need to for this particular use case. So you can see it comes in on a daily basis. The data we want to ultimately be modeling at the end of the day, which is some sample data from Lending Club, is monthly. So we're gonna convert that daily data to monthly data. I'll just show you guys. This isn't really anything to do with Snowflake, honestly. These are just how I like to work with time series inside Posit. So even though this is nothing, I guess this isn't like a Snowflake capability, the fact that I can just run this natively on Snowflake is still a really big deal to me, because this is kind of my most comfortable coding environment. I don't have to like relearn any new grammar. I can stay completely on Snowflake, but use my tools of choice for working with time series. So for converting daily time series into monthly time series, I use this really nifty function called summarize by time. It's in the time TK package. And I can say, well, I want to summarize yields, and I want to get a monthly treasury yield. There actually is no such thing as a monthly treasury yield. There are only daily yields, even intraday yields, because it's a constantly fluctuating time series. So when we or anyone talks about a monthly yield, you have to kind of figure out, well, what do you mean by that? I'm just going to take the average yield. You could have said, I want the max, I want the min, I want, I guess, the median yield on a monthly basis. I'm just going to take the average yield. There's obviously some problems with that if we think there was a day or two in a particular month where yields really spiked and we had some outlier yield. But for all intents and purposes, this tends to be pretty good. So we can use, again, summarize by time, and that's going to give us our monthly treasury yields for 2 years and 10 years. So again, what I'm ultimately wanting to do is take this, join it up with the Lending Club data that we ultimately want to model, which is on a monthly basis as well. So, one of my favorite things about R, and probably a lot of other people's, is the ability to use ggplot to visualize data. So I just took that treasury data, plunked it into a ggplot workflow. Just more of a sanity check than anything else. Make sure there's no holes. Make sure there's no gaps. Make sure there's no huge spikes, which might indicate a data issue. You can see there really aren't any huge spikes here. Normally, it would probably alarm us to see that the 2-year, the green line, has made its way above the red line for most of the last few years. That's typically considered a bad thing. It's called an inverted yield curve. People sound the alarm about that a lot. They think it means a recession is coming, but alas, no recession has come. Typically, we would probably want to investigate that, though. That's a little bit of an unusual result, but in this case, we're just going to kind of ignore that. So we have our data. We've converted it to monthly. Again, this is all running in the Snowflake cloud, even though I'm just coding this up in R, using all the tools that I like to use in R. At this point, though, we've just kind of imported the data, turned it over to to monthly. If I really want to use this for modeling, there's a few things that I would typically do. So first, I want to lag this data a little bit. If I want to see if treasury data is going to help me in some way model consumer lending data, it's probably not going to be a coterminous relationship where treasury yields today are somehow affecting consumer lending on that exact day. Typically, we would expect there to be some sort of a lag. So I'm going to take these two time series and lag them. I'm going to break them up into different columns just so it's easier to see. So we'll run a pivot wider on that. Again, I wouldn't want to have to do that in a different language because this is how all my code flows go. And then we're going to do something that I call lagging at scale. I'm going to take advantage of this mutate across vocabulary, which I find super, super useful. And I'm going to create a 1 month, 2 month, and 3 month lag of both our 10-year and 2-year treasuries, right? And I've kind of put a thing here. We could keep going. We could make a 6 month lag, a 9 month lag, a 7 month lag, however many lags we wanted to create. And we can do it across every single column that contains the word year. So again, this is very, very typical when we're getting into engineering features around different macroeconomic data. We want to create a lot of lags. So bang, we've created a lot of lags. I'm going to do the same thing with the rolling means because I want to create a whole bunch of rolling means. I'm going to use mutate across again. And now I feel like I've got my data into how maybe I want to actually use it for modeling. So I'm going to save it as an object called treasuries monthly with lags and rolling mean for DB. So very, very verbose name, but I wanted to make it verbose so that we could kind of keep track of what's going on. And I'm going to take that data, visualize it real quick. I'm going to save it back to Snowflake. So this is a really important step because now I'm actually writing data back to my Snowflake environment. That means that myself and my fellow R coders can always access this data now, but it also means that other modeling teams can use this data too. And this is a really, really important point about the Posit Workbench, which is that as more and more companies are kind of migrating to Snowflake and different cloud providers, if our teams don't have a way to run natively there, then it's hard to actually share their work, right? You can always kind of write it back up to the table. But again, that will involve going outside of the cloud environment and bringing data back into the cloud environment. So you're writing stuff back, but where's it being written from? Once you can kind of work here natively in Snowflake and then write your data back as you want. So we just did some kind of light feature creation around these treasuries, but we could have done some heavy feature creation, and we might want to save that back to Snowflake so that other people who maybe they're not R coders, maybe they want to use a different environment, but they can get access to our work too. I'll talk a little bit more about that in just a second. But anyway, so that's what we've done. We've kind of created some new features, and now we're gonna kind of walk through what James talked about, that blog that I referred to, which is really, really good if you have a chance to look at it. We're gonna model this lending club data, right? And we're gonna try to basically model or predict the interest rate that is charged on all these different loans. So I'm gonna stick to the lending club data from just the year 2015. That's 421,000 rows. So nothing too big. I think if we did everything, we'd be above 2 million. But I just kind of chose us for 2015. So I'm gonna filter down to that year. I'm just gonna grab a couple of columns, not everything. BC util and BC open to buy interest rate. I'm going to grab the issue month and issue year, and then once we collect this into our environment, we're gonna mutate that into an actual date. Once we mutate it into a date, that'll let us join up our treasury data, right? So again, this is just kind of working through the data. We're going to collect it into our environment and then run a quick mutate so I can get a date on this lending club sample. Okay, so this is all building towards actually modeling this data. This is the visualization of what it looks like. Pretty hard to see a trend here from a time perspective. I guess it gets a little bit, the spreads, I guess we could say, are widening as we go through 2015. The interest rates are absolutely out of control. As you can also see, some of these are above 15%, which is absolutely nuts. But be that as it may, we're going to take that lending club sample data, join up our treasury data with it right here. So again, we're just doing all of this in R, but it's running in Snowflake. And that's going to give us, obviously, our interest rate with a few columns that came in the data set, and then a few columns that we created from our 10-year and 2-year data. Okay, now here's where the really fun part starts. We save that back to Snowflake in case we want to use it again. And now we can start modeling this data. So what that means is we have the full the full array of tidymodels available to us. So we're going to create a recipe for some feature engineering. We're going to run that recipe. We're going to normalize all of our numeric predictors. We're going to run imputation on these two that have a few NAs in them. And then we're going to get rid of any NA that we might have missed anywhere else. So this is kind of a feature engineering recipe that precedes running our model. We're going to choose to run a linear regression model. Again, all these steps are kind of detailed in the Orbital blog post. And then we're going to set up this workflow to run the model, to run the recipe, and then eventually we're going to fit that model and calculate some metrics. Okay, this is all in the blog post. If you're familiar with tidymodels and you're familiar with recipes and Parsnip, this all probably looks pretty comfortable, and hopefully it looks pretty awesome because we're again running all of this natively on Snowflake. Where this gets super interesting is with this new Orbital package. So what Orbital lets us do is once we fit this model, Orbital is gonna basically convert that workflow into code that can be executed directly on Snowflake. When I say directly, I mean it's not going to be executed necessarily in this native app. It's going to be executed back in a Snowflake warehouse using native SQL. That's going to make it super fast, and it's going to let you take advantage of all the partitioning that Snowflake does. Really, all the stuff that makes Snowflake really fast. Now we can take advantage of that while we're fitting a model, basically, or say while we're running a model. So the kind of way this flow goes is that we use the Orbital function to turn that lending club fit object. And remember, that included the recipe for feature engineering and the fitting of the model. So that's going to give us this object. We don't have to run this next one, but we can. It will show us the SQL that's actually being created. So this is what's actually running in Snowflake, which has the best SQL engine in the world. And then we can run predictions on this, right? So this would run predictions for us on, I think I only put this down to like 400,000 observations. The blog runs it across over 2 million in 2.5 seconds, which is really fast. But this is a really powerful thing that honestly it's pretty new. I think it's only been out for about the last 4 or 5 months, but it's a huge leap forward in how we can start with RStudio, Posit as a native app. Again, doing all the work we want to do using R, using the grammar we're familiar with, in the Snowflake cloud. So everything's staying secure, everything's staying governed. We can write our object back to Snowflake. But then Orbital lets us take either our recipes, our models, and then run them as native SQL inside Snowflake. So then we get the benefit of the fastest SQL engine in the world to run these models. Like James said, it doesn't cover every single model that's inside of tidymodels. So the documentation specifies which ones are there exactly. There's quite a few, and it's the same for recipes. It doesn't have every single step recipe out there, but it does have almost all of them. I only have 1 or 2 minutes left. There's one more thing that I just want to kind of point out. So you can see from that we've kind of created our SQL here around these recipes. And I talked about saving data back to Snowflake. One more thing to kind of point out in Snowflake is that we just launched about the same time as this native app, actually, in the last 9 months, our own native feature store. So feature store is a place to both store and track the features that you've engineered to run your models, right? This is becoming like, it's always been kind of a best practice, but now that we've opened this up to our customers, the adoption of that feature store is going much faster as companies try to not just de-silo their data, but try to de-silo their feature stores. So with this workflow and the ability to save your data back to objects inside Snowflake, you could easily then create a workflow that would take those objects and plunk them back into the feature store so that other modeling teams, maybe modeling teams that don't use R and don't want to use R, maybe they want to use Julia, maybe they want to use Python, whatever it is, they should be able to take advantage of the features that you've created. And likewise, our coders should be able to take advantage of any features they've created by accessing the feature store. So it's kind of creating this unified hub for all these different features, and it really should be language agnostic, right? So that's something that Snowflake's trying to enable, because it's all stored natively in Snowflake. As long as it can be accessed via SQL, which it can in most of those IDEs, all these teams can kind of work together. So I hope you guys are as excited about this this capability as I am. To me, this is bringing together two of the most performant, efficient, and really, as James said, it just works pieces of software in Snowflake and Posit. Being able to run R natively inside Snowflake like this, something I've always wanted to be able to do. And the Orbital package really just takes it to the next level, honestly. So with that, I think we're going to do some Q&A here at the end, if I'm not mistaken.
Yeah, I can share a couple thoughts just to wrap things up, Jonathan.
I will stop sharing here, James.
Perfect. Yeah, thanks for walking through that. I think just to kind of recap, right? Like, we on the Posit side have been I can't emphasize enough how excited we've been about the work we've been able to accomplish with Snowflake in such a relatively short period of time. We went from not really having much context around the native app infrastructure and Snowpark container services to having a working version of Posit Workbench relatively quickly. And we view a lot of this as just the beginning of a foundation that we plan to build on for the foreseeable future. We talked at the very beginning about some of the context around all of our professional products. We focus primarily on Workbench today, and that's because that's the first piece that's available inside of this native apps and Snowpark container services infrastructure within Snowflake. We are hard at work on bringing the other products that we offer to that same sort of deployment pattern. There's some work that's happening on the Snowflake side to support us there. There's work that we're doing. We don't have a time frame on when we expect those to be available at this point, but it's something that we're conscious of and working diligently towards. I've also pulled up just a couple of links. These have been shared in the chat, but if you wanted to grab them from here, you have access to the partner page that we have for Snowflake that just provides some details and context around our partnership with them. And then we also have that blog post that Jonathan's alluded to a few different times and that we've, again, kind of shared some links to in the chat. And then finally, if you want to reach out and get a hold of either of us, you can reach us here. If you're interested and you are a Posit customer today and you want to kind of experiment with this or understand a little bit more, you can reach out to your customer success representative. Or if you're not a current Posit customer but would like to try this out, you can reach out to sales@posit.co and we can make sure that we get you the evaluation licenses that you would need to get this set up and configured on your end if it's something that you're interested in. But I know there's been a few different questions that have come through. I'm actually going to just turn the time over. We've got Nick Pelican, who's joined on our end to help kind of moderate any questions that have come in. So we'll go ahead and move to a Q&A portion of our webinar here.
Yeah, and great to meet you all. Nick Pelican. I'm a senior solution architect at Posit, and I cover mostly financial services. So, and thank you to Jonathan and James. That was super awesome. Love seeing macroeconomic data be used in Posit Workbench, in the Posit Workbench native app. I think just to kick it off, we have a couple different questions. One from Slido and Dominic on the YouTube chat. Both ask kind of similar questions around how much memory is available to R. Is this running in the Snowflake native app? Is this running on a Snowflake warehouse, or like how do you assign compute to this app?
Yeah, I can take that one, and then Jonathan, if you've got color you want to add. But the current implementation today is that when you subscribe to the application and then your Snowflake administrator configures it, one of the things that they set up is the size of the compute pool that is available to the app inside of Snowpark Container Services. That compute, like Snowflake provides a very wide range of compute pools or compute instances. So you can have something really small, you can have something really big, you can have something in between. But that defines what local resources are available. So if you set up this with an instance with 64 gigabytes of memory, then that's the memory you have available. If it's 128, if it's 250, whatever the number is there, that's what's available, and it's shared across all users who are concurrently accessing the app at any given point in time. The other side of this, though, is that one of the great things about working with Snowflake and R is that it's very easy to connect to Snowflake data and then just keep the data in Snowflake while submitting queries that get executed as SQL rather than pulling all the data locally and working off of it there. And so if you employ that pattern, you end up not requiring as much local memory in most use cases because you're just letting Snowflake be the execution engine. And in that case, all the compute is defined by the warehouse you've connected to with your connection.
Yeah. Just to kind of echo that, I'll say two things. I mean, so one, just to pick on what James was just saying. So if you notice a couple of the code snippets where I wrote collect in my code, that was bringing the data in locally, you could say, right, into the app. Before you run that collect statement, you're kind of executing everything pushed down back into the database. So you can do a lot of filtering, selecting, kind of down sampling before you actually pull your data in. So that's one way to kind of keep things, to kind of manage your memory and CPU needs. But I'll also just say, I mean, to scale up, like James was saying, we have customers who need to scale up and down from very, very small to very large workloads inside Snowflake. So again, it's kind of just managing those compute pools, like James was saying.
Awesome. We've got another question from Atang, who asked, will this support ETL pipelines from on-premise databases?
My perspective on that one is I think the best practice there in my mind would be to configure that ETL process to happen kind of however you want, such that the data lands itself inside of Snowflake. The easiest path here is if you have everything available to you that you need from a data perspective inside of Snowflake, then this becomes a really easy process. If what you're trying to do is take the native app, take this service that's running inside of Snowpark Container Services with Posit Workbench, and then like reach out to some other data source that's not Snowflake, things get a little bit tricky there because there's some networking restrictions and requirements that come into play, and it becomes a little bit more of a, like the configuration becomes a little bit more nuanced at that point. And so we've seen the most success, and our perspective has been this will be, you'll be best served in this case if all the data that you need is available to you in Snowflake, which means if you need to do some ETL stuff, you should certainly do that. Just don't try to, I wouldn't necessarily try to orchestrate it from the Workbench side.
Yeah, completely agree with James. I mean, if there is data like that on-prem, I would say your question might be, well, how do I know if I want to migrate all of my data into Snowflake before I've even gotten up and running with this? And I would say, take a sample of your data, put it into Snowflake, and then make sure that you're kind of getting the value that you're looking for before, if you don't want to like take the decision to migrate, an entire on-prem database. But long-term, as James was saying, that's going to be the best, most effective workflow you've got.
Great. Drew is curious about approaches to automated workflows of Workbench for R code and Snowflake. Orbital seems like one cool approach. Are there any others that you would highlight?
Yeah. So we view Workbench primarily as an interactive tool. So I come in, and the best practice use case there with Workbench is I'm a developer and I'm doing what we just saw Jonathan do, right? I'm looking at data, I'm exploring it, I'm visualizing it, I'm learning about it, but it's all this sort of like real-time interaction that takes place. When we talk about automated workflows, that's where something like Posit Connect starts to come into play, because now I can like publish something that I schedule, whether it's a report or just a script that I want to run every so often. Posit Connect provides a much more robust set of tooling to manage that process long-term and to define scheduling and everything else like that. Posit Connect isn't available inside of Snowflake today. It's something that we're working on, like I previously mentioned. The other side, though, is what we see with Orbital, where I can take some sort of a workflow or workload that I define inside of Workbench and then convert it to something that can natively operate within the context of Snowflake itself. In this case, the model object to some sort of SQL definition that Snowflake can execute on. Snowflake's first language and still language of choice remains SQL. And so there's nothing else that comes immediately to mind. I don't know if Jonathan's aware of anything that provides like an Orbital-like experience for other tasks, but it's certainly something that's well worth kind of understanding if there's other use cases that might benefit from this type of like transformation from R to SQL execution.
Yeah, I would say in terms of automated flows, SQL is definitely going to be the way to go. Even Python will be easier to automate inside Snowflake, because you can kind of schedule those. But if you want to automate native R code, Connect is still the best way that I know of doing that, which I know unfortunately it doesn't yet run natively in Snowflake. Hopefully it will soon or someday. But to me, that's still the best way to automate any R code that you have. Yeah, so for now, the Orbital is going to be the way to go when possible.
Awesome.
Yeah.
And we have a question from the Slido on what does the Python functionality look like in a native application? How would you compare that to alternative Snowflake functionality for Python IDEs?
Yeah. You want to take that, James? Or want me to take it?
I can take my first pass at it. So within the native app, right? So within Posit Workbench, you've got access to not just RStudio, which is where we spent the bulk of our time today, but you've got Jupyter Notebook, Lab, VS Code. The next release of Posit Workbench into Snowflake will include support for Positron, which is our next generation development environment for both R and Python. We've worked hard to make sure that all the different Python frameworks that are commonly used by Snowflake users, whether that's the Python SQL connector, or that's the Snowpark framework, or whatever it might be, including like things like the VS Code extension, that those will work with the features that we've built into Workbench related to Snowflake, primarily the authentication stuff. So if I've come into the native app and I'm running Posit Workbench on Snowflake, and I sign in and I say, here's the role that I want to use, and then I launch VS Code, I'll be able to open up the Snowflake extension within VS Code, and it will automatically be connected into my Snowflake account. I won't have to go through like a separate configuration process to get that going. If I wanted to orchestrate workloads using Snowpark or using the Snowflake SQL connector, the Snowflake Python connector, those will all just pick up on the authentication that Workbench is offering. That's the biggest benefit there, right? Like then I can use those frameworks just like we saw on the R side. I can then just write and execute code like I would. The interaction between the code and Snowflake is the authentication piece is already taken care of for me.
Yeah, just the last little bit I'll add to that is that there's something nice and really, if you have an administrator and they really just have to manage Posit Workbench, and that gives you RStudio, VS Code, Positron eventually, Jupyter Notebooks. So it just kind of lightens the administrative load to just have one place to manage, one IDE to manage, really, not one IDE platform to manage, right? Sitting on top of one cloud warehouse to manage in Snowflake, right? So it just makes things, I would say, easier administratively, so that resources can kind of be deployed elsewhere.
And I'll just add to that, because I am personally a Python dev by training. I love, and I'm a VS Code user. I love the fact that I can have VS Code running in Snowflake now. It's awesome. And we've got about 2 minutes left. Just to wrap up, we've got a couple questions, both from Slido and from Dan in the YouTube chat, about what happens for those who don't have a paid membership for Posit Workbench. Or can you talk about what this looks like without using Posit Workbench?
Yeah, happy to. I love this question because our goal is to provide the right balance there, right? In terms of, we don't, for any number of different reasons, you may not have access to Workbench. So what can you do? And a lot of what we've covered today, Orbital's open source. The way that you connect from R into Snowflake is through the ODBC R package. That's open source. So if I wanted to, let's say that I was just using like RStudio at the desktop level, right? So Posit Workbench is not included at all. I can connect to Snowflake using ODBC. I can pull data down into my local session. I can build a model on top of it. I can use Orbital to convert that model into SQL. I can submit that SQL back into Snowflake as a stored procedure. None of that requires the use of Posit Workbench, right? Now, when it comes to operating and having access to the RStudio IDE within Snowflake itself, that does require having a valid Posit Workbench license, because the only way that is possible is through the Posit Workbench native app that we make available. So in terms of accessing Posit tools directly within Snowflake, yes, you are going to need to have a license for that. But if it's just a matter of I have Snowflake and I know R and I have RStudio, whether it's RStudio server open source or I have RStudio on my desktop, and I want to be able to experiment with Orbital, or I need to be able to orchestrate some of these workflows, 100% all that's supported and available through the open source packaging that we provide.
Awesome.
I'll just add quickly that before this native app existed, that's what I used to do with my RStudio instance. I just connected from either my desktop or from a different server somewhere else, and I connected up to Snowflake to run on my work. So it can be done, and it's very effective.
Awesome. I think that brings us to time. Thanks everyone for joining. Thank you so much for all the great questions. As James mentioned, if you have any questions, please feel free reach out to James, Jonathan, sales@posit.co. We'd love to hear from you, and we'll see you down the road. Thanks, everyone.
Yeah, thank you, everyone.
Thanks for coming, everyone. Appreciate it.